During middle school, students are taught a function that consists of a polynomial of degree 1. This turns out to be a linear graph, which is cool and all at first, but it's rather bland. It changes at a constant rate into infinity, and, well, nothing much really is happening. However, if we square the input and get a polynomial function of degree 2, we enter a completely new world of non-linear functions. It is here where it gets more interesting, as by definition, there is no constant change. The result is an arc-like graph. We can notice that the whole world around us is made up of many parabolas. Take for example a water fountain. How about a banana? Then there's also the Eiffel Tower, the McDonald's logo, King the Ka, rainbows, Gateway Arc. Wait, apparently rainbows and Gateway Arc are actually not parabolas. Which brings up a point, that not every arc-like curve may be a true parabola. Another thing to keep in mind is that what we will be examining soon might vary, so it might not be a true parabola all the time. And what exactly will we be examining? Turtles. The green sea turtle to be exact, because their shells are rather smooth compared to other turtles. As you can see here, the turtle's shells vary of course from turtle to turtle, so let's just take a random one. We'll be taking the top curve of the shell. Let's put a graph on the turtle. According to National Geographic, adult green sea turtles are up to 5 feet in length. The turtle spans x values from negative 11.5 to 10.5. This adds up to a total length of 22 units. Assuming that this turtle is an adult and is the max size, we can get the scale of the graph. Using dimensional analysis, we get a final answer of approximately 2.7273 inches per unit. So let's choose our first point. I'm going to place the first one where the parabola seems to end on the left. That looks to be about negative 9.4, 0.8. Now let's do the same for the second point, but this time let's put it on the other end of the parabola. Now it gets a little gray here, where the parabola seems to end and turn into something else. But let's just say that the parabola begins to fall off around 4.2, 2.4, which turns out to be a coordinate palindrome. Now for the third point. Let's put it at where the parabola seems to max out, which seems to me about negative 0.7, 3.17. For the fourth point, let's choose a point in between the leftmost point and the middle point to get something like negative 5, 2.55. Finally, for our fifth point, let's choose a point in between the rightmost point and the middle point to get about 1.8, 2.97. We now have our 5 points. Now let's find the quadratic regression equation. As you see here, I plugged the values into a graphing calculator. The resulting quadratic regression equation is y equals negative 0.0310956638x squared plus negative 0.0426367112x plus 3.13830491, with r squared being 0.99967286663. We can therefore conclude that a green sea turtle shell is very close to being a true parabola, but not quite. This, however, could be a result of human error. Let's check that our quadratic regression equation works. For the sake of ease, from now on, when using the quadratic regression equation, the numbers will be rounded to 4 decimal places. With our rounded quadratic regression equation, y equals negative 0.0311x squared plus negative 0.0426x plus 3.1383. Let's input negative 2 to get another point to make sure that it matches the curve on the turtle shell. We plug in negative 2 for x, square this, multiply those, and add them all together, which gives us 3.0991. This point does indeed lie on the turtle shell, so this equation works. Using this quadratic regression equation, we can find a supposed vertex of the shell. Using the axis of symmetry formula for a parabola, negative b divided by 2a, we can get the x-coordinate of the vertex. Let's plug in b and a. Now multiply b by negative 1. Then multiply a by 2. Now divide the numerator by the denominator. We now have the x-coordinate of the vertex, approximately negative 0.6849. We can then input this value for x in our quadratic regression equation to get the y value of our vertex. Let's plug in negative 0.6849, square this, multiply both of these, and add all of this together. What we have now is the y-coordinate of the vertex, which is approximately 3.1529. Therefore, our vertex is approximately negative 0.6849, 3.1529. To find the y-intercept, it is very simple. We just take the constant term at the end because the other two terms will evaluate to 0. Our y-intercept is approximately 0, 3.13. And I believe that's it. Here are some interesting facts about sea turtles. Did you know that green sea turtles can live for 80 years or more? Did you know that green sea turtles can weigh up to 700 pounds? Did you know that juvenile green sea turtles are omnivores, but adults are herbivores? And so concludes our mathematical investigation. I hope you enjoyed.